Hi everyone and welcome to the Learning Curve Academy. In this video, I will be focusing on differentiation, looking at typical past paper questions in the calculus portion of mathematics for economics, social sciences, or business past paper for students in level 1 at universities. In this particular lesson, we will be applying various rules of differentiation to solve problems, including the chain rule, the product rule, and the quotient rule. Here we are told to find f prime x, which is the first derivative of the given functions. So let's go about solving these problems. So to find f prime x for this function, there are some important things that we need to recognize. We're asked to find f prime x for f of x equal x to the fifth power plus 1 all raised to the power of 6. Well, when we are differentiating bracketed functions raised to a power other than 1, then the useful rule to apply, or one of the most useful rules to apply in differentiating such functions, is the chain rule. So the chain rule can be applied in differentiating this function, f of x equal x to the fifth plus 1 all raised to the sixth power. And that is because the chain rule is extremely potent in differentiating bracketed functions which are raised to powers other than 1, like this is. So to do that, we will apply the power rule principle within the application of this chain rule, first and foremost. So we're going to bring the power of 6 down to the front of the bracket. So this will be 6 multiplied by x raised to the fifth power plus 1. And we subtract 1 from this power of 6 to give us 5. So that is the application of the power rule principle. Then we're going to multiply by, to complete the chain rule here now, we're going to multiply by the derivative of what is inside the bracket. So we're going to differentiate what's inside the bracket and multiply by that result to complete the application of the chain rule and hence the differentiation of this problem. When we differentiate x to the fifth, applying the power rule principle, we will get 5x raised to the power of 4. Power of 5 comes down to the front of the x, and we subtract 1 from that original power of 5, giving us 5x to the fourth power. Since the question says we do not have to simplify the answer, we could have stopped there. However, I'm going to go a step further by multiplying the terms that are not inside the bracket here. So 6 multiplied by 5x to the fourth power. 6 multiplied by 5 is 30, so that will be 30x to the fourth power. And then multiplied by x to the fifth plus 1, all raised to the power of 5, which is in bracket here. And we leave it at that. So that is very much an acceptable form in which to leave this derivative in. So that is how we apply the chain rule to differentiating bracketed functions which are raised to a power other than 1. Let's look at the second question. In the second one, we have two terms that are being multiplied by each other. So we are told that f of x is equal to x squared ln 1 minus 2x. The two terms that are being multiplied here are x squared and ln 1 minus 2x. That's a whole term, ln 1 minus 2x. So what we're going to do here is that we're going to assign one term in the product as u and one term and the other as v in order to apply the product rule, because this is a product. And to differentiate products, the product rule is typically used. The product rule is given here in the problem, which says f prime x is equal to v times u prime plus u times v prime. And that is the rule that we're going to apply here. So I'm going to call x squared u, and I'm going to call ln v minus ln of 1 minus 2x v. You could call any term u and any term v when applying the product rule. It does not matter. So f prime x is equal to, so let's now differentiate this product. F prime x will be equal to v of x, just write in the formula here, v of x multiplied by u prime of x. So v of x multiplied by u prime of x plus u of x multiplied by v prime of x. So basically, in the first side of the sum, we write back v as assigned, multiplied by the derivative of u. Then we, on the other side of the summation, we write back u as assigned and differentiate v. So let's go about doing that. So we're going to write v here. V of x would be ln 1 minus 2x. That is what we assign v as. So we just write it back here for v of x. Multiplied by u prime x, which means that we're going to differentiate the term that we assigned as u. The term we assigned as u was x squared. So when we differentiate that, the 2 comes down to the front. So that's 2x. And we take 1 from the power. So 2x is the derivative of x squared. Plus u of x, in which case we write back the term we assigned as u, which is x squared. And we're going to multiply by v prime of x, which is the derivative of v. Since we assign v as ln 1 minus 2x, then the derivative of v would be 1 over 1 minus 2x. Yes, so 1 over 1 minus 2x. So this is how you differentiate an ln function. Ln here is the natural log. So we're taking the natural log of 1 minus 2x. When you're differentiating the natural log of a linear function like this, we just take 1 over that function and multiply by the derivative of the function, 1 minus 2x. When we differentiate the denominator here, 1 minus 2x, we'll just get minus 2. Because the derivative of 1 is 0, because 1 is a constant, and the derivative of minus 2x is minus 2. Okay, so that's times minus 2. So let's now simplify this. We can further, now based on what the question said, we do not have to simplify the answer. We could actually stop there. We're going a step further. I'm going to re-express this as 2x ln 1 minus 2x. I just put the 2x at the front of the product. The order of multiplication does not matter. And it's more aesthetic to write the 2x at the front here. Plus, now I have 3 terms basically making up the product on this side of the addition. X squared, 1 over 1 minus 2x, and negative 2. So I'm going to multiply out the numerators here to simplify this. That is x squared by 1, which is x squared, multiplied by negative 2, which is going to give us negative 2x squared. So we could just write this in its simplest and most direct form as negative 2x squared divided by 1 over 2x. And we're going to leave it right there. Okay? So that's a simplified version of the answer. And that's how we apply the product rule to differentiating products. Finally, in this illustration, I will apply the quotient rule. So here we're given a quotient. A quotient is when you're dividing one function by another. So to apply the quotient rule, which is given here, and I'll restate it as part of my solution, we apply the numerator as u and the denominator as v. For simplicity, it is recommended that when applying the quotient rule, you apply the numerator, the top half of the fraction as u, and the bottom half as v. So f prime x here would be equal to v of x multiplied by u prime of x. The formula is very similar to the one used for the product rule. But here we're going to subtract u of x multiplied by v prime of x, and we're going to divide all of that by v of x all squared. So we divide that by v of x all squared. So when I differentiate here, this becomes v of x is what we assigned as v, which is the denominator of x plus 1. So this will be x plus 1. And u prime of x would be the derivative of what we assigned as u. We assigned e to the 4x as u. So when you differentiate an exponential function like this, e to the kx, where k is a constant, the answer is ke to the kx. So therefore, when we differentiate e to the 4x, we would get 4e to the 4x. Yes? So that's u prime x. Now minus u of x, which is what we assigned as u, which is e to the 4x. Here we're going to multiply by v prime x, which is the derivative of v, which is very simple. The derivative of x, which is the same as 1x, is just the coefficient of x, which is 1. And the derivative of 1, which is a constant, is 0. So that's all for the numerator, divided by the denominator, which is v of x all squared, which is x plus 1 all squared. Again, based on the fact that the question says we do not have to simplify, we could stop right there, but I'm going to take it another step, guys. So I'm going to write this as 4e to the 4x, x plus 1. So basically what I've done here is that I've just rewritten the product. So not much happening here apart from the fact that I've just rewritten the product by putting the 4e to the 4x before the x plus 1, which is more aesthetic. And then on this side, e to the 4x multiplied by 1 is just e to the 4x, because any term multiplied by 1 gives us back itself, all over x plus 1 all squared. Now I could stop there, but I'm still going to go one step further to show you how we could really manipulate this function, this result, to reduce it to a low form. When we look in the numerator portion, we realize that e to the 4x is common to both expressions on each side of the minus sign. So we could factor out e to the 4x because it is an HCF. It's the highest common term to both sides of the subtraction here in the numerator. So factoring out e to the 4x out of the numerator will give us 4x plus 4. Because when I factor out e to the 4x from this side here of the minus sign in the numerator, I just be left with 4 multiplied by x plus 1, which is 4x plus 4. And when I factor e to the 4x into negative 4x, that is when I divide e to the 4x into negative e to the 4x, I will just get minus 1. So this makes the function much simpler and easier to handle. So this becomes now x. We of course still have x plus 1 all squared in the denominator. And by further simplification, this will become e to the 4x into, now 4x plus 4 minus 1 would just be 4x plus 4 minus 1 is 3. And this is going to be all divided by x plus 1 all squared. So that's all divided by x plus 1 all squared. Okay? And that is in a low form, a very reduced form, and we are going to leave it right there. And this is how you apply the chain rule, the product rule, and the quotient rule in differentiating functions. I'll be doing further lessons on differentiation in which you will learn more about these rules, the chain rule, the product rule, and the quotient rule. I hope you found this lesson to be very straightforward, easy to follow, and I look forward to seeing you again soon on the learning curve. Remember to like, share, and subscribe. Thank you.